Okay, so we're going to take a quick look here at comments within Java, and we've talked about them a little bit already, but we have a couple of different ways that comments can work, and so more often than not you'll see inline documentation, and so those are within the program. They're followed with the / and they should explain kind of the purpose and the processing steps. They don't need to necessarily your variable names, and you don't need to explain what a for loop does or what your conditional is, or what your variable is. That should all be apparent within the program, but we should have the ability to kind of see overarching stuff of what's going on with it. The computer just ignores them. They're not for the computer. They're for a programmer that picks up your program to kind of see what's going on with it. And we can really have three forms that they look. So this comment will take up that line, and then it will end. And the key part of that is our // So anything that begins with the / is going to have will be ignored by the computer and is just seen as a comment. For the other type, we can look at this allows you for line breaks to be created. So anything within the / and the two / here and here is going to be a comment. And then the last piece is for a Java doc, and this is the /*, and then it'll end up with a //. And these are really important as we start to create our own methods. So here's an example. If we just look in a document that we looked at in class, we can see we have these inline comments that are created here. This line will only cover line 6. It has to have its own comment, the // after it, otherwise it won't continue. Here we have multi-line comments with the /*, and if we look at this, let's say we wanted to create another method that was our method. So let's just say we copy this down, and we're creating another method, and just to keep it simple, we'll call it mine. And then we'll just change one little piece, hello, and put our semicolon. And now if we want actually something to show up, so let's save that and compile it, no problem. We can look at the Java docs pretty easily within BlueJ by toggling that, and we can see our method shows up, but there's nothing really there. It doesn't explain anything. It just has the method header. And so if we go back into our actual view, we can add some Java documentation with the //, and BlueJ will complete that for us. So I just hit enter, and it automatically completed that documentation, and I could say something like, this is a simple method that just prints hello. And I'll say later, delete this, so I know that it's just something that I've used. So if I compile that, and now I go back to the documentation view, that will show up in that piece. So anything that I put in there will help somebody with understanding my method and my class structure and all that good stuff. So it's important to use documentation so that this is kind of the view that the world will get of your program, is the Java documentation. And so if we don't use comments, then no one's going to be able to understand our code very easily. Alright, we also have identifiers within Java, and so they're just words that we use in the program to identify things. So again, we try to name things for what they are. So these are just identification pieces, and some of them are already used and reserved, others we can make up. Usually we'll talk about this in terms of variable names. You can use a variable in terms of letters, digits, underscore character, and a $sign within there. You can't begin it with a number though. So if you were trying to make a variable, you could call it my variable, and that's fine. This, where we have the ability, we have a capital M and a capital V, that's called camel case, and so we would usually in Java use camel case to create our variable names. It's something like Python. You would have something that looks like this maybe. You would have my underscore variable That's just a Python convention. In general, we're not going to use that in Java. It doesn't work. It's just not the convention. Um, you can't though. You'll get an exception if you have something like this, where you say one my variable. All right. It won't allow you to start the one in that place. Now you could, if you wanted to, put a one at the end, and that's totally fine. Um, and in general, you'll get, this would be it's not a great example. It's kind of a horrible name because I don't know what my variable does, right? So I wouldn't use that, but it shows you the example of kind of how you would go back and forth with these pieces. So here's a better example. And one thing to keep in mind is that these are case sensitive. And a couple of these, it would depend on what we're talking about here. But in general, if we start it with a capital letter, that would signify a class. That's not really what we're talking about here. This would probably be our best choice. This, where it's all capital letters, you can use as well. That's not a problem. But this would be for a constant. That's our convention. Again, the compiler's not going to kick you out or throw an error if you use total, and total is something that can change if it's all capitals. But in general, you're going to confuse people if your constants aren't capitals like that. All right. So again, this is what I was just talking about. We capitalize the first part for class names, uppercase for constants, and then your other variables will have the conditions that are met by what we talked about above. All right, and you get lots of practice with this as we go. Here's some more. Right, we have identifiers that people have already created. So something like print line, right? That is something that has already been coded into Java API, and we can't use that, otherwise it would be confusing. And those are called reserved words. And you can't change a reserved word. And here's a list of our Java reserved words. You'll see that a lot of them you might not know what they are right now, but you'll see them as we start to get through it. So like at the bottom, there's our int, that's before our integers or whole numbers. We have double, that's our floating point values. We have while, true, this is a Java reserved word. All this other stuff, super, else, all that pieces that we're going to use down the road. There's one goto that's a reserved word but isn't actively supported right now in Java. It's kind of a holdover from other languages. And so it's some of you that have had experience with C or a C variant will use goto statements. We don't use those in Java as of now. One other thing to think about in a Java program is white space. So those are spaces, blank lines, all those tabs, everything else in between there is ignored by Java. It's there for us to space things out appropriately. If you want to see what a computer needs, go and look up like a minified JavaScript file, and you'll see all that stuff is taken out. And it's really hard for a human to read, but just as easy for a computer to read. So space stuff out. There's no reason to jam it all together. Make it easy to read at this point. We're not looking at efficiency at this stage, so just make it legible. But you can format stuff in lots of different ways, and you'll see in a second here that it doesn't really matter how we format it. There's different ways you can look. So this is an example of a poorly formatted code. Things are kind of just jammed together if we go through this, and we can see that we don't have the nice easy spacing on it. We can look at this in BlueJ, and the coloring that BlueJ is trying to help us with is a little bit off. It looks like this might not even compile or work or run, but it works out that if we compile it, it does compile. You can see at the bottom there's no errors, and we can run it, and it will give us the same output as the first one. A more extreme case is this one, Lincoln 3. Right? Everything is all over the space. It's been spaced out, tabbed, but it's still in the correct order as our nicely formatted first one. And this one, again, looks like a mess, but it'll still compile, and there's no syntax errors. And if you run it, it's going to be the same thing, and it still works. So avoid stuff like this where it's really it's a mess. I don't think you would go this far. But the good thing about BlueJ is if you have something like this, it's really easily able to kind of tell what's going on with it. And the color coding, whether you like it or not, you can turn it off if you don't, is really helpful for your structure as you're learning how to do this. Okay, so we've talked about this kind of briefly in class already, that we have different language levels, and the machine language is your bytecode. That's what the machine can understand. And then we have assembly language, which is an intermediary part, which some people do right. And then Java is a high-level language. Almost every computer programming language, for the most part, that you're going to encounter is a high-level language. And so that's kind of where we engage on it. We need to get every machine into its own specific machine language in terms of how it understands. So the machine language on an Apple is not necessarily the same as on a PC. And so Java has came up with different ways to approach this. But at its heart and soul, a program has to somehow get translated into a particular type of bytecode, zeros and ones, binary digits, that the CPU for that machine can understand. So we use a compiler that takes source code and turns it into bytecode. But we would have to, in some sense, have a specific compiler for each type of CPU we would encounter. And so the way that Java approached this is a little bit different, and really has what made Java unique and powerful. So Java has this intermediary step, which sounds like it is more work, but it actually takes that source code and turns it into a special Java bytecode. There's something you probably heard about called the Java virtual machine. It doesn't necessarily work for any CPU, so it's not geared towards a PC or an Intel or a Macintosh computer. What it does is it has specific Java bytecode that runs within this thing called the Java virtual machine. And then the interpreter takes that and writes it for your Apple, for your PC. So we don't have to worry when we're writing in Java about how to compile it for Macintosh or for a PC. That's taken care of by somebody else who is an Oracle writing the virtual machines for this. So we talk about this. It's said to be architectural neutral. You can write once and it'll read everywhere, and that's been the power of Java traditionally as we go through. Alright, so this comes to be something that we call the Java Virtual Machine, or the JVM. You'll see it in different places. But basically, you write at this part, you write Java source code. It gets compiled into Java bytecode, so that's one step removed from what the machine needs. And then we don't ever worry about this part, the Java interpreter, the bytecode compiler. That's specific for each type of machine, each type of processor. But that gets taken care of into something the machine can read. And so Java has kind of streamlined that process in a counterintuitive way by adding an extra step in here. Alright, and then we're going to get into our development environments. The one that we're going to start with is BlueJ, but there's lots of different ways that you can do this. NetBeans is another popular one. We're going to try to stay away probably from Eclipse to start with. But if you need to install these, they're pretty straightforward. You can just Google BlueJ or NetBeans. One thing that you need to make sure of is that you have a Java development kit within your installed on your computer. Alright, so this is what I'm talking about. If you just search for BlueJ, it'll show up as right here, and then it immediately just have the download and install. And your options are for Windows or Mac. It even has a Linux installer if you need it. More often than not, you're going to want this one that includes the JDK. I'm not quite sure which version of the Java development kit that has, but I'm sure it's relatively recent. This will allow you to actually write Java code. So your computer can run Java, which almost every machine has Java installed, but you don't necessarily have a development kit. So that's one I would go with. If you want to be more specific, you can actually go to Oracle and download the latest and greatest Java JDK. And then you can also get NetBeans here as well if you want, which will include your JDK. NetBeans is a little bit more complicated, and we'll talk about down the road. Okay, last thing for this section is we're going to just talk about syntax and errors and the different types of errors that we can see. And so we're going to have lots and lots of errors, and we want to recognize them for what they are. You're going to start off with just a lot of syntax errors. These are errors where you have just typed something in incorrectly and Java doesn't know what you mean. We're also going to have logical errors, and we're going to have different pieces as we come through here. So we have syntax errors or compile time errors. This means that it can't go past the actual words or symbols that you've typed there. It doesn't understand what you mean. So you can get a compile time error or syntax error really simply. You leave off a semicolon, you mistype something, it won't move forward. We can also have things that are called runtime errors, which everything compiles fine and that seems to work, but when we actually run it, we have something that the machine can't deal with. So a classical one is division by zero. It'll compile fine, but when you try to run it, it'll encounter an error. And then the hardest ones to get figured out are actual logical errors. So we can have something, it compiles and it runs, but it doesn't actually do what you want it to do. And those are the ones that take time to actually sort out and fix. And you might have to revisit your design process as we go through this. So we can look quickly at kind of two of those three. So it's really easy to get a compile error or a syntax error. Just almost change anything in your program. So get rid of a parentheses and try to compile it, and you can see it popped up this red thing. If I look here within the editor, it'll try to help me out by putting it'll highlight the line and it'll tell me what it's looking for, so I can put that back in. Sometimes and now it compiles fine. Sometimes the errors are less clear, so if I take out a quotation mark and I try to compile, right, again it freaks out and it highlights that line, and this one maybe doesn't make as much sense right now, but it says unclosed string literal. This is a string of text, string of characters, and we need to close that with our quotation mark. So that's a way that we get a syntax error, and you're going to get a lot of those initially. If we're talking about a compile error, I'm sorry, a runtime error, so if we have int x equals 3 divided by 0, that's an undefined value. We could say, all right, if I compile that, no problem, it compiles, there's no syntax errors. If you try to run that now, you're going to get an issue when it gets that line. And so you can see that it highlights it, you say it can't actually divide by 0. Someone tries to carry that out, you get an error. A logical error, again, is harder to figure out. Let's say that we are trying to set a variable equal to the square root of some number. So we had math dot square root -4, and we compile it. Oops, I have an incorrect data type. So that was trying to help me out. Let's make it a double, not an int. Compile, no errors. And then if I actually run this, it'll run no problem. But let's say that I was supposed to find a solution, a real solution to a number, and this could be an imaginary solution. So that's a logical error. That's not a computer issue, it's a me issue, and those are the ones that are the most difficult to fix.